All right, so if I come across a system, there's several different options. We can use elimination, substitution. When we get to a larger system, though, 3 by 3, 3 variables, 3 equation systems, it gets a little more complicated. And so what I'd like to show you is just this Gaussian elimination with back substitution, which we kind of previewed it last time a little bit. But let me start with a smaller one, the 2 by 2, 2 equation, 2 variable system. Minus x plus y equals 4, and 2x minus 4y equals negative 34. All right, so typically, yeah, we would solve that probably with elimination, but let me show you this Gaussian elimination method. It uses matrices a little bit, and then we'll venture into the 3 by 3 mode. Of course, yeah, like I said, we're going to use the matrix alternative here, so maybe I'll do that. Just use the coefficients of your variables and then the constant, of course. And so that would be the top line, and the bottom line would be 2, negative 4, and negative 34, right? All right, so what this Gaussian elimination, if we do that, what it relies on is we need this diagonal here to just be ones, and then the below the diagonal would be zeros. And in this case, so we need to make this and this be 1, and then that, we need that to be 0. Maybe not in that order, but so yeah, the first matter would be to make this a positive 1, which all you'd have to do is divide, right, row 1, divide that by negative 1, or multiply by negative 1, however you want to think of that. So yeah, we're just dividing each of those by negative 1. And we'll do it all separate here. Now we need, like we said, we want this term to be 0 because it's below the diagonal, if you will. And so to make it 0, when I add to it a multiple of this row, which I'd be negative 2 times this row added to row 3. So I'd keep row 1. As is. But I would take, to make this 0, I would take negative 2 times row 1 and then add it to row 2. And that'll make that term 0, and it makes the rest whatever it is. But so what we're saying is take negative 2 times this, which would be negative 2, and add it to the row 2 entry there, and that'll give us 0. That's what we want. Now, we've got to do it on the, to make it legal, we've got to do that all the way across, so it'll be negative 2 times that, which would be positive 2, plus then the row 2 entry, which is negative 4. And that's going to be negative 2. And then same thing here, negative 2 times that would be 8, plus then the negative 34, and that would go in that place right there. It should be 20, negative 26. And then last but not least, like we said, we want this to be a positive 1, and so finish off the Gaussian elimination, that part of it anyway. We're just going to take and divide row 2 by negative 2. So that'd be 0, 1, divide that by negative 2, you got 13. And what that does is, yeah, that gives us the solutions, because now the top line, if we put it back with the x's and the y's, that would be 1x minus 1y, just minus y equals negative 4, and this would be just y equals 13. And so we've got it, because now we can just say, well, x minus 13 equals negative 4, so that would make x be 9. probably a little a little longer than if we just did it by elimination, but it's a good example to show you how this is going to work. Because with a system of 3 equations, 3 unknowns, yeah, it gets more complicated. So that's why we're going to do those with this. All right, any question? All right, so let's start with it. 2x minus 5y plus 5z equals 17. And then x minus 2y plus 3z equals 9. And then negative x plus 3y equals negative 4. Okay, so let's solve using the Gaussian elimination. And really what the matrices do for us is it just gets rid of we don't have to write all the x's and the y's. I guess we could leave those in there, but you don't have to with the matrices here. Okay, so put it in a matrix here. We've got 2, negative 5, 5, and 17. And then 1, negative 2, 3, and 9. And then we got negative 1, 3, 0, negative 4. We don't have a z term in the bottom one, so need to fill that in with a 0. Okay? Now, I want to make this as easy on ourselves as possible. And you see, one thing we haven't talked about yet that we can do on this one, that we didn't do in the previous one, is we can swap rows out. And in this case, swapping a row out is going to help us a lot because row 2 already has a 1 in the first slot here. And so if I swap those 2 out, right, that'll give me my first 1 in the right proper spot. So that saves us a little bit of. So the first thing here is let's just swap row 1 and row 2 out and make it 1, negative 2, 3, 9, and then 2, negative 5, 5, 17, and row 3 as is. All right. I guess we could have done that at the beginning too. I want to save even a little bit further, but anyway, that's another thing we can do besides the other things that we talked about. All right. Now, again, with this Gaussian elimination, we want to have 1s along the diagonals and then 0s below that. And so 1s along the diagonals, but we want 0s below that, right? And so that's our next thing is I want this to be 0 instead of 2. And so how would I do that? Well, I'd take negative 2 times row 1 and add that to row 2. And that'll get the 0 that I want right here. So leave row 1 as is. And then negative 2 times row 1 plus row 2. So that'd be negative 2 times that plus the row 2. That'll give me the 0 there. But I got to do that all the way across. So negative 2 times the negative 2 would be positive 4. Add that to the negative 5 from row 2, and that'll give me a negative 1. Negative 2 times that is negative 6 plus the row 2 entry, which is 5. So that'd be also negative 1. And then negative 2 times the 9 would be negative 18, plus then the row 2 would be 17. Everybody with me on that? Same thing for row 3. I want a 0 here also, because it's below the diagonal. So how would I get rid of it?
Will we not have to deal with that -1 in the second first? Or does it matter?
Well, let's combine it, kind
Okay.
of combine some steps here. Yes, we are gonna have to divide this second row by -1.
Okay.
That's next step. To combine steps here, let's go ahead. It's real easy to combine because couldn't I just add row 1 and row 3, and that gets me a 0 here, doesn't it?
Yeah.
So that is one thing we could combine in this step with that. So yeah, now we're just adding row 1 and row 3. So that'd be 0, what would that be? +1, 3, and 5.
So would we solve the second line then again, or would we swap it and then solve it with row 3?
We could, yeah, I see that. That's not what I
Okay.
previously did, but yeah, she was saying, well, could we swap those? Yeah, you could. You saw that. But let's just go ahead. Let's keep these same order. Let's just divide row 2 by -1. Pretty much the same thing. So that'd give me 0, 1, 1, 1, and then 0, 1, 3, 5. It might be, it would have probably been better to do that, because now what we're gonna have to do is take row 2. So I'm good on the first 2 rows, because I got 1, 1, and then 0 here. But now I need this to be 0 because it's below the diagonal again, so I need that to be 0. So take row 2 times -1, so -1 times row 2 plus your row 1, row 3, sorry. And that'll give me my 0 here, because that'd be -1 plus 1. -1 plus 3, the next one would be 2, and then -1 plus row 3 would be 4. And we pretty well got it, because now all we have to do to get the, that needs to be a 1, got the 0, zeros, below the diagonal, need that to be 1, so. So all I'd have to do is divide row 3 by 2. Shrink it down a little bit so I have room. Yeah, so now, I shouldn't have put that dotted line through the whole way, but now I pretty well got this knocked out, because the top line, put the x, y, and z back in. That would be x minus 2y plus 3z equals 9. Second line would be x plus, y plus z, there is no x, equals 1, right? And then the last line is z equals 2. We got this thing figured out, because now that's the back substitution part of this. Now I've got z equals 2, so I can plug in that to get the y. Y would be -1. And now I can substitute both of those back into the first one, right? We got this knocked out. So it'd be x, that'd be plus 2, and that would be plus 6. So it looks like x plus 8 equals 9. That'd be x equals 8. Which they would probably write in the ordered triple x, y, z. Okay, so there you go. Question or concern?
Can you do another one?
Let's do one more. I have one more. Let's try it. Because you do sometimes have to deal with some fractions or decimals. It's not too bad. All right, so here's the third. Negative 2x plus y plus 4z equals 14. 4x minus y plus 3z equals negative 2. 3x plus 5y minus z equals 15. Gaussian elimination, back substitution. Okay, so negative 2, 1, 4, 14. 4, negative 1, 3, negative 2. 3, 5, negative 1, and 15. Okay, yeah. So this one, unlike the previous one, doesn't have quite the nice line. None of the rows are nice, are they, as far as having the one entry that we like? So we'll have to figure that out. So, I mean, none of them look any better than the other one as far as making the first entry 1, right? That's what I'm saying. So let's just stay with what we got. How would I make that 1? Well, just divide it by negative 2, right? So row 1 divided by negative 2 with the goal in mind of making that a positive 1. Well, that's going to give us one decimal or fraction. 1 divided by negative 2. That's not a whole number. Let's just call it negative 0.5. The rest of them are okay. 4 divided by negative 2 is negative 2, and 14 divided by negative 2 is negative 7. And we could combine some steps here, but let me just do that one on its own. So now what do we need? Well, the next thing, we go down, we need this to be 0, because the diagonals we want to be 1s, which they almost are, but it doesn't really matter because this is not 0. Below the line is not 0. That's really what we want to look at next. So I need that to be 0. So I would take what? Row 1 times negative 4 and add that to row 2 to make that a 0. So negative 4 times row 1 plus your row 2 will give us the right entry for that. Top line stays the same. Then I take negative 4 times row 1, so that would be negative 4 times that would be negative 4. Add that to the 4, that gives me 0. Negative 4 times that would be positive 2, plus then the row 2 entry, which is negative 1, that would give me, oh look at that, that's positive 1. Negative 4 times that would be positive 8, plus the row 2, be 11. And then negative 4 times that would be 28, plus then row 2 would be 26. Okay? Now again, if we can combine some steps here, let's go ahead and make that a 0 because we also need both of these to be zeros. So we can work, next step would be to make this 0. So we would take negative 3 times row 1 and add that to row 3 to give me the 0 entry here. That would be negative 3 plus 3, that would be 0. Negative 3 times that, okay, so I'm going to have to contend with some more fractions here. So negative 3 times the negative 0.5 would be positive 1.5 plus the 5 would give me 6.5 for here. Negative 3 times that would be negative 6 plus the negative 1, that'll be negative 7. No, sorry, positive 6. Try that again. It's negative 3 times row 1, so that'd be positive 6 minus 1, so that'd be a positive 5. And then negative 3 times that would be 21, plus the 15, so that's 36. How's that look? Well, now we're good on the row 2 because we've got 0 first entry and 1 is the second entry. So we've got our diagonal 1 there that we want and the 0 below the line. So that would just mean I need this to be 0. Because again, the diagonal is 1s. So I need 1, 1, 1, but I need this to be, these other 3 to be 0. So I need that to be 0. So the way I'd get rid of that, easiest way would be to take row 2 multiplied by negative 6.5. So let's keep the top line, 2 lines are okay. There might, for future reference, you might have to, if this wasn't 1, we would divide it by whatever to make it a positive 1. But in this case, it is positive 1, so we don't have to do that. So now we just take negative 6.5 times row 2 and add that to row 3. Easiest way to get this to be 0. So we want that. So make that 0. Yeah, that would be negative 6.5 plus 6.5, so that's 0. Let's see. Negative 6.5 times 11. What is that? That's something. Negative 6.5 times 11. It's negative 71.5. And add that to 5. It's negative 66.5.
Yes.
And then negative 6.5 times 26, is negative 169. Add that to the 36, so negative 6.5 times that, plus the 36. It's negative 133. Okay. That works out pretty nicely because now, to get that to be 1, all I have to do, keep the top 2 lines the same. That needs to be 1, so I divide by row 3, divide that by negative 66.5. We've got our shape that we want, the form that we want. And it turns out that that's come out to be nicely. Negative 66.5 divided into that is just 2. So we've got it. Diagonals are 1s, below the diagonal is 0s, so we've got this system solved. This would be x minus 0.5y minus 2z equals negative 7. That would be y plus 11z equals 26, and that would be z equals 2. That's the one we're looking for. Back substitute now, so z equals 2, so we have y plus 22 equals 26, so that's y equals 4, right? And then substitute those two back into the first equation, z equals 2, y equals 4. So we have x minus 0.5 times 4 is 2. And then minus 2 times 2 is minus 4. So that's x minus 6 equals negative 7, so that means just be negative 1 for x. So negative 1 for x, 4 for y, 2 for z. There you go. All right. A little bit of a process, but like I said, those 3 by 3 can get complicated.